Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you are doing well. Uh, Today we are here for the online course in Organic Chemistry 2 with the course code CHEM-312. Today is our first lecture, and the topic of the day is Introduction to Solvents. So, the layout of my presentation will be: we will discuss the following subtopics: solution, solvents, dielectric constant, dipole moment, melting point and boiling point, heat of fusion and vaporization, and classification of solvents. So, before moving on to today's proceedings and start with the solutions, uh, I would like to remind you that most of the inorganic reactions are studied in aqueous medium, as water is the best known solvent due to its high value of dielectric constant. Uh, Nevertheless, the many non-aqueous solvents have also been studied extensively in the last few decades. A large number of non-aqueous polar solvents such as liquid ammonia, glycyl acetic acid, sulfuric acid, anhydrous, sulfur dioxide, and halides of hydrogen have been the subject of interest, and in fact they have been introduced, and very interesting reactions and structural motifs have been studied in these solvents. So basically the behavior of any solvent can be determined on the basis of several properties, including physical as well as chemical, which will be discussed in today's lecture. So we start with the solution. Solution, as Ostwald, according to Ostwald, almost all the chemical processes which occur in nature, whether in animal or vegetable organisms, or happening in non-living surface of the earth, those always take place in the solution state. Simplistically, solutions can be defined as homogeneous liquid phases consisting of more than one substance in variable ratios, where one of the substance is so-called solvent, which itself could be a mixture. This is treated differently from the other substances, which are known as solutes. Usually, solutes is a minor component, while the solvent is always in excess. The interest in this field of the non-aqueous medium basically arises from the study of two scientists, Saint Giles, who were working on the esterification of acetic acid with ethanol. So they noted for the first time, and that paper was reported in 1860s, and later on in detail in the 1890s. And they reported that the influence of the solvent is very crucial, not only on the rates of reactions, but it also affects the reaction products as well. So the primarily the chemical structure wasn't considered important, of great much interest for the chemists, but later on, after these experiments, which proved not only the rate but mechanism, it affected the mechanism of the reaction as well. So it means that it wasn't only the physical phenomena which were considered previously. Later on, they started thinking about the chemical nature or the structure, rather than the physical properties of particular solvents. And after that paper and other papers reported by different scientists, it was decided that solvent should not be treated as a macroscopic continuum characterized purely by physical constant, but also as it is continuum consisting of individual mutually interacting solvent molecules. These macroscopic and microscopic approaches must be considered together as defining the general concept of solute-solvent interaction. This concept involves and influences all of the following: the macroscopic, that is the bulk properties and physical properties like refractive index, relative permittivity, density, etc. And on the other hand, the microscopic intermolecular forces like ion dipole, dipole-dipole, dipole-induced dipole, hydrogen bonding, electron pair donor or acceptor behavior, and solvophobic interactions as well. And number three, solvation in multi-component systems involving selective solvation, and finally a chemical solvation related to ionization and dissociation processes. Generally, what we have learned so far, the solution is a homogeneous mixture of minimum of two or more substances. Type of solutions: unsaturated solutions. This is from your basic chemistry knowledge. These types of solutions which are commonly known to an undergrad student: unsaturated solution, saturated solution, supersaturated solution. So you are quite used to these terms. So these are also the types of solutions. And then we move on to the other type, more specific: isotonic solutions, then hypotonic solutions, and hypertonic solutions. Considering the solid, liquid, and gas phases, the matter exists in these three phases. Nine possible combinations have been discussed. For example, if a solid is solute in a liquid, so that is a type of solution. So example of that is salt in water. Then we move on to liquid solute in liquid. So example of that is vinegar, while the soft drink is an example of gas solute dissolved in liquid. Then we see the behavior of solid solute in gas. So mothballs are the examples of that, while humidity is an example of liquid in gas. That is a solution of liquid in gas, while the gas acting as a solute in another gas. So such a homogeneous mixture, the example of that is air, while considering the solid solute in solid, so that example is gold in silver. And then liquid solute in solid, so dental fillings are the examples of those types of solutions. Then we move on to solvent. So it means that solvent is of primary importance. So we have to consider the role of solvent. It is extremely important. Now we have learned that solution is a priority medium for the chemist to work with. There are reasons why we are interested in solutions. First is the availability of solvents, second, the solubility of substances in given solvents, and above all, the ease and the utility with which we can deal with the solutions makes this form of the treating material is very attractive. Now, solvent being very important in terms that it dissolves solute. Uh, the basic theme behind the role of solvent against the solute is that this solvent is whenever something that is soluble in a given solvent, a solute that is soluble in a solvent, what happens in fact when we dissolve, for example in your home, what you do that you a few we place put a few crystals of either salt, table salt, or table sugar inside a glass of water. What happens that, and stir those, after some time the solid disappears. So basically what happens, you have made the solutions of salt and sugar respectively. So where did the solute go? Why did the solid disappear? The reason for that is the forces of the solvent, the bonding forces of solvent overcome the intermolecular bonding of the solute particle or entities or the moieties or the ions or the radicals, and then those forces, when those forces started breaking this, they got weak, and resultantly what happens that they gradually disappear and we have the solution. Now this solution is of great interest. Why? Because we have to study chemical reactions, we have to study chemical properties, we have to study the synthetic pathways as well. So the part of solution, so this is the importance of solvent in solution. The part of a solution that is present in the larger amount, or the compound that is normally liquid in the pure state or dispensing medium of a solution, is called solvent, while the substance dissolved in a solvent to make a solution is known as solute. So, the definition of solvent, this is the definition of solute, and their interaction resulting in the formation of homogeneous mixture is known as solution. The process is known as solubility. Sometimes it is also called dissolution, or the process of salvation. Okay, so next we move on to different types of solutions. As we have seen, there are different types of solutions based upon the nature of solvent as well as solute. So the primary condition and the most important condition that makes a substance solvent. The primary and the most important condition are the vital condition that if this condition is not met, you are unable to claim that a certain given substance is a solvent for a given solute, and that is the inertness of solvent towards that particular solute, because it is mandatory that this should never ever react chemically with a given solute. If it reacts, then it's no more a solvent, then the solvent becomes a reagent. Then this is the first condition, and then there are certain factors which affects the process of solubility. Why we are interested in these factors? A reason for that is, if we know these factors, we can go for a better choice, a good choice of a solvent which is suitable for our requirement. Then is the behavior of solvent. So with all these properties, keeping all these properties in mind and the factors, we will be able to study the behavior of a solvent, and in that way we can select a solvent for a given chemical reaction or a given chemical property. So we move on to next slide, and the topic is dielectric constant. So dielectric constant for is based upon Coulomb's law, and Coulomb's law is given by this equation that F is equal to Q1 by Q2, Q1 into Q2 divided by dr square. Q1 and Q2 are oppositely charged entities which are connected together by means of this distance r square, and this is the force which is holding these things together, and d is the constant because F is directly proportional to these things. The force which is holding these things together is directly proportional to Q1 by Q2 into Q1 into Q2 divided by R square. And when we remove the proportionality, then a constant is introduced. This constant is known as dielectric constant. So it means that this distance, if R increases, force weaken, and if this decreases, force will increase. So these things are inversely proportional. So generally dielectric constant is denoted by kappa, which is actually the capacitance of a given, excuse me, which is the capacitance of a given substance to its capacitance in the vacuum. Next we move on to dipole moment. Dipole moment is basically a very interesting property of a solvent, that greater is the polarity of a given solvent, how a solvent is polar, So that will actually give us the dipole moment. That will be indicated by the magnitude of dipole moment. So dipole moment is basically the vector sum of bond moments in a molecule. That is a measure of polarity of that particular molecule, and molecule is obviously as a solvent molecule. This is actually the measure of the degree of polarity of a polar molecule. Then we see the dipole moment. It is often expressed by dBi units, and those of some of the selected solvents have been given in the following table, like here, that is of HCN, HF, H2O, ethyl alcohol, sulfur dioxide, liquid ammonia. So these are the some of the examples of dipole moment, and these indicate while going down the table there is a decrease in the dipole moment, so polarity is decreasing on the while we go down this table. Next is the melting point and the boiling point. Melting point and boiling point actually gives us the range or the workable range of a solvent, that during this range, these temperature ranges uh, on either extreme melting as well as boiling. So after melting, it's understandable a solid will be converted into liquid, and while at the boiling point, that particular liquid will start evaporating in there. So between the melting point and the boiling point, this gives us the workable range of a particular solvent. So this is extremely important because this will give us the workable range of a given solvent. For example, in case of water, the melting point is 0 while the boiling point is 100, so it's a sufficient enough uh, temperature range for making it a very good solvent. Then these things can be understood in terms of critical point, that is the critical temperature and the critical pressure. So these can also give us very interesting indicators about the liquid range of a solvent. Next is the heat of fusion and heat of vaporization. Heat of fusion is the amount of heat that is required to melt 1 gram of a solid uh, at its melting point with no change in temperature. So, and the next is heat of vaporization, the amount of heat that is required to vaporize 1 gram of liquid at its boiling point with no change in temperature. The units for both are joules per gram. So the nature and strength of intermolecular forces in the solid and the solid state are indicated by the molar heats of fusion. Here are some of the heats of fusion, and the heat of vaporization, and some of the characteristic or selected solvents have been given. Next is the classification of solvent. Solvents are basically classified in 3 ways. The first classification is based upon the proton donor or acceptor ability. So based upon this, the solvents are classified to be protic or protonic solvents. These are further classified into protogenic or acidic solvents. These are known as to donate hydrogen ion easily. So examples are HF, H2SO4, acetic acid. Then we have got protophilic or basic solvents. These have got the tendency to accept hydrogen ion readily. So examples are ammonia, hydrazine. Then we have got the third subtype, that is amphiprotic or amphoteric solvents. These have got the dual character. These can accept as well as donate electrons. So examples are water, ammonia, acetic acid. Second class is aprotic or non-protonic solvents. So these neither donate nor accept hydrogen ions. So examples have been given, the carbon tetrachloride and chloroform. The next way of classifying solvent is based upon the polarity of the given solvent. So polar or ionizing solvents are highly polar solvents, and these furnish autoionization or self-ionization phenomenon. The molecules, due to this autoionization or self-ionization of the solvent, are highly associated, hence they have higher boiling points, like examples are H2 and H3, HFSO2. Then we have nonpolar and non-ionizing solvents. They do not ionize at all, do not furnish auto or self-ionization, hence weakly associated due to nonpolar nature. So they have low boiling points, like benzene, carbon tetrachloride. Third classification is based upon a very simple rule, that is water a solution of water are known as aqueous solvents, while all other solvents are known as non-aqueous solvents. So that was all about today's lecture. And next is the references. You can, I will suggest you for further reading. So thank you very much for your queries. I will be waiting your queries at my email ID. Thank you very much.